A set is another collection that we get to talk about, and it has a very important and a specific property. It doesn't allow duplicates. Now, I should start by saying that we're going to talk about other things you could do with the set in the collections, right? But specifically, we're going to do another video specifically talking about doing the difference, the union, the intersection of sets. So that's coming, but just to kind of highlight what's the big deal with a set. Well, I said something like this, where we have, let's just say numbers, some integers like this, and I can print my set, do a little bit of code, you save it and run it, and you can see that we get a set. And we know that we could also print the type, and that should be a set as well. So we know that. So that's a set. A couple of things to note though. When you do something like this, an empty set, you don't get a set. This is probably the most important thing I want you all to remember. You get a dictionary. What's a dictionary? Well, we know it's a key value pair, and or many, right? There could be more than one, but that's what you get. So you don't want to make that mistake initializing something like this, thinking it's a set, even though it is a set when you put some elements in it. So, but what else can you do? So we can kind of highlight the important things of this set is that you could do things like this, right? You could say my set dot notation. You'll be able to see all the different methods that you could use. Let's add a number here. Let's say 19, and you know what we'll do is we'll do exactly the print statement afterwards as well, and we'll see that we added 19. Now the set, along with the other properties, another main property that it has is that it's not ordered, and you can see here it's not ordered because it had 1, 2, 3, and then I added 19, and then 19 was you would think if it was ordered it would be to the end of the set, right? So it would be 1, 2, 3, and then 19. Well, look at how 19 it added it at the beginning, and in fact you can't really tell or predict the order. It could be, if you run this a whole bunch of times, maybe it's the same, maybe it's not, but you can't guarantee, you can't count on that, right? Same thing happens here. If you do remove, you could remove 2, and let's print it, and you can see that well, here it looks like it's about the same, but again, you cannot guarantee the order of the set, so therefore you can't even, and it's unindexed for that reason, so it makes sense, right? So you can't say something like, hey, in my set get me, well, in my set get me index number 1, right? Or number 0. You can't do this. It is not subscriptable. It's not, you can't index it, it has no order. So intuitively that makes sense. And by the same token, what else? Those are the big two things I wanted to keep in this video, but just be mindful that there's more coming. These collections have other things that we could do, other methods that we could do, whether it's, you know, again, the union, the intersection, the difference, dealing with some of the overloading operators, right, like plus and minus, and we'll see that. That's coming. But I'm hoping that this starts to make sense about sets. The last thing, I guess it's a little trick, I could put it in the next video, but might as well just put it on this one, is the following too. Like just one thing that we know we could do. We've seen it before, but might as well see it with this set type, right? So we can say something like, hey, take this set, and I want you to go ahead and make it a list, right? And then print everything like the type and the set, and we can see that it goes from set to a list. And what that allows you to do is you could again add elements to it, and then when you don't want to have those duplicates. Let's just say that we wanted my set to have, let's append the number 3. And you can see that here we're going to have 2 3s. Actually, I'm not printing this again. Let's print it. Let's print it here. Let's print it afterwards like this. Let's print it. We'll see that we have 2 3s. And then what we can do is just say, hey, look, why don't we go ahead and take the set. I'm just trying to be a little bit lazy here, but no typing. And let's create this as set, and then print the set and the type again. And we'll see that the last element is going to be a set, and we do remove any duplicates. By the way, not to pull a fast one here, but it's nothing to do with all this casting that I'm doing. But you could say something like this: hey, I want many 3s here. That's a set. This is valid. It's just that when you assign it to the set, it's not going to contain duplicates, right? So Python interpreter, when it adds the 3s, if it already had one, it's not going to show a difference because it already added one. So it's going to rewrite to that same value, and you get something like this. So it's a great way to remove duplicates from a collection, and you can see how you can have a tuple and make it a set. You can cast it over. You could do a list. You can do many things, right? And cast it over. So it's just a very neat idea that you could do something like that.